All right, folks, in this video, what we're going to now focus on are 4 more of the points, and I call them the points that are at a 30-degree angle from the center. Okay, let me show you what that looks like. See this one right here, this point, and this point, and this point, and this point. All 4 of those points are at a 30-degree reference angle from the center of the circle. So if I put a 30-degree reference angle here, see this? We got a hypotenuse, that's going to be our radius. That's, in this case, a radius of 5, and we're at a 30-degree reference angle. Over here, this point right here, also, look at that, a 30-degree reference angle up from the center. And now, if we look at these 2 down here, you can see that this point right here is also at a 30-degree reference angle from the center. And this one over here is as well a 30-degree reference angle from the center. So these 4 points, right, they create a sort of rectangle, right? Kind of a wide but flatter rectangle. Those are all what I call the 30-degree reference angle points from the center. And I'm going to show you how to identify the coordinates of those 4 points. Okay? So I want to review and I want to recall the relationship on a 30, 60, 90 right triangle. That we know that if the hypotenuse of a 30, 60, 90 right triangle is equal to, let's say, h, that's the hypotenuse, then the short leg of the 30, 60, 90 is going to be h over 2. It's going to be 1/2 of h. So if h was 5, like in this case the radius of the circle is 5, then the short leg would be 5 over 2. And so then the long leg is equal to the short leg, h over 2, but multiplied by the square root of 3. So in this case we would do the square root of 3 times the hypotenuse divided by 2. Divided by 2. Okay, so what we're looking at here now is when we put, actually let me leave that there. When we put a 30, 60, 90 right triangle in here between the center and the point that we're trying to identify, here's what we can identify. We know that the radius is the hypotenuse, right? So this is the radius. And therefore, the vertical distance here, the y, the change in y, is the short leg. And so that's always going to be whatever the radius is divided by 2. That's the vertical distance. And then the horizontal distance is going to be that same value, the radius divided by 2, but also multiplied by the square root of 3. So what we're going to have is the square root of 3. Really, actually, I'm going to change this. I'm going to make it, instead of square root of 3 times r, I'm going to make it r times the square root of 3. R times, that r looks a little bit like a square root symbol. R times the square root of 3 divided by 2. That's our horizontal distance. So in this case, since our radius is 5 and our center is at 7, 9, we can change this r, this radius, to a 5. And we can change this radius to a 5. And so the distance, the horizontal distance over to this point, from this point, we're traveling from the center and we're traveling horizontally over to here, which is a distance of 5 square root of 3 over 2. And so the x coordinate is increasing by 5 square root of 3 over 2. So the x coordinate of this point is 7 plus 5 square root of 3 over 2, comma. Now if we want the y coordinate of the center is 9, and then we're going up by 5 over 2. So all we have to do is 9 plus 5 over 2. And these are the coordinates of that point right there. And you can write it just like that. That's fine. You don't have to simplify it. I'm okay with you leaving it like that. Now, over here, on the left side here, I'll put a different one. Let me put this one in here. It's a 30, 60, 90 right triangle again. And so the hypotenuse, again, the radius is 5, and that means the short leg is 5 over 2, and the long leg is 5 square root of 3 over 2. And so the coordinates of this point, if this is 7, 9, the x-coordinate is going down by 5 square root of 3 over 2. So we're going to subtract 5 square root of 3 over 2 from 7. So the coordinate here is 7 minus 5 square root of 3 over 2, comma. The y-coordinate here is 9, and we're going up, so we're adding. And how much are we going to add? Well, the distance from here to here is 5 over 2. So that's going to be 9 plus 5 over 2. And so now we have the coordinates of that point. Now let's get the coordinates of this point down here. Let's see here. Put in a 30, 60, 90 right triangle here. We've got a radius. The distance from the center of the circle to the edge of the circle is 5, which is also the hypotenuse of this right triangle. And the short leg of this 30, 60, 90 is going to be 5 over 2. And the short leg of this right triangle, 30, 60, 90 right triangle, is going to be 5 over 2. And the long leg of this 30, 60, 90 right triangle is going to be 5 square root of 3 over 2. And so our x-coordinate of this point is 7 minus this distance. And this distance is 5 square root of 3 over 2. So that's going to be 7 minus 5 square root of 3 over 2, comma. The y-coordinate is 9, only now we're going down, so we've got to subtract this distance, which is 5 over 2. So that's 9 minus 5 over 2. And now we have the coordinates of that point. Last point, last of these points. Let's come over here. The 30-degree reference angle point here. Put in our 30, 60, 90 right triangle. The radius from here to here is 5. That's also the hypotenuse of this 30, 60, 90 right triangle. So the short leg is going to be whatever the hypotenuse is, 5 divided by 2, because we know that the length here is half of the hypotenuse, right? And then the distance from here to here is this number times the square root of 3. So that's 5 square root of 3 over 2. That's a terrible 2. Sorry about that. I don't leave very much room. That's 5 square root of 3 over 2. And so this point, the x-coordinate, is 7. This is starting at 7, 9, and the 7 is going up. So we're going to add this distance, which is 5 square root of 3 over 2. So 7 plus 5 square root of 3 over 2, comma. And the y-coordinate is going down. It's below the center, so we're going to take 9 minus. So it's going to be 9 minus this distance, which is 5 over 2. And that's the coordinate of the fourth point. Now, if you were to say to me, hey, how about a circle that has a center at, let's say, negative 3 and 10, and you told me that the radius was 2. Well, let's not make the radius 2. Hang on, then I'm going to be forced to reduce a fraction. How about the radius is 21? And I want to identify these 4 points, okay? Well, the 30-degree angle in the kind of the first quadrant is up and up. So that's going to be, the x-coordinate is negative 3, and then I'm going to add to it radius 21 square root of 3 over 2, comma. The y-coordinate is going to be 10 plus the radius 21 over 2. So that's going to be one of the 4 points. The second one will be negative 3 over here. I'm subtracting from the x, minus 21 square root of 3 over 2. And the y-coordinate is going up, so I'm adding. So it's going to be 10 plus 21 over 2. For the third point down here, I'm going to subtract and subtract. So I'm going to do negative 3 minus 21 square root of 3 over 2, comma, 10 minus 21 over 2. And then lastly, I'm going to add to the x and subtract from the y. So I'm going to do negative 3 plus 21 square root of 3 over 2 and 10 minus 21 over 2. And these would be the 4 points that have a 30-degree reference angle from the center. Okay? We're only going to do one more video on this. And in that video, we're going to identify the points that are at a 60-degree reference angle. And what you're going to find is that we're going to use all the same numbers that we used from the 30-degree. We're just going to flip the x and the y. We're going to flip the number that we're adding and subtracting between the x and the y.